we now move to the phototube. Now the phototube is a practical application of the photoelectric effect. So the photoelectric effect is the liberation of electrons from a surface when light falls on it. So over here we have a stylistic version of the phototube, and that stylistic version of the phototube shows us a large circular or semicircular cathode, and in front of it a collecting anode, which is just like a pin. Over here we can see what it looks like in reality, these type of tubes. Now what they are used for is that they're normally switches which detect light. Say for instance we have a street lamp, and the street pole there has a light hanging over here, and we want that light to turn on at night. So we will put a phototube on the top of that, and during the day when light falls onto this phototube, there will be emission of photoelectrons from the surface into the collecting anode, and therefore we would detect a photocurrent. Now remember, photocurrent is simply the electron emission. Now at night, this the light goes, and therefore the photocurrent ceases. And we use a secondary circuit to detect the fact that there is no current, and when that happens, we use the electricity from the grid to turn the lights on. So the phototube is a great switch to be able to turn lights on and off, or activate switches if we want light and dark to be sensed. So let's just check on how this works. Now once again, we'll just quickly recap what is the photoelectric effect. The photoelectric effect, if that's the surface, inside the surface we have electrons. So let's put some electrons here, and there's a sea of electrons in the surface, or these electrons can be bound to the lattice. And what happens is, let's just make sure we know that these electrons, we'll put some little E's around, okay. And if we have incident light, so let's say we have light coming in here. Now this light coming in is in the form of a photon. So photons are both particles and waves. And these particles, these photons have energy E equals hf. If this energy is exactly correct for an electron to be liberated from the surface, then the electron becomes, or one or more electrons might become stimulated, and they become energized, and they leave and move to the surface, move away from the surface. But to be totally liberated from the surface, they have to pay back to the surface amount of energy so that they can be totally liberated, and that amount of energy that they must pay back is called phi, where phi equals the work function. Now the work function is the amount of energy that the electron needs to give back to the surface so that it can totally leave. That means that an electron which is emitted and leaves has E equals hf, the original amount of energy that it got from the photon, minus the work function. If we consider this, there's going to be a specific value of f, the frequency of the photon, this f here, that is required to overcome the work function. We call this lowest value of f the threshold frequency. So we'll give f0 the simple threshold frequency. Okay. And this is0 when the sum total of all the energies would equal 0. So to find threshold frequency, we say 0 would equal, let's just rewrite that out. We know that E equals hf minus phi, and we want E to be 0. It's the value to which these two become balanced, and that becomes hf minus phi. Therefore, hf would equal phi, or threshold frequency would equal phi on h. Now, h, of course, is Planck's constant, which is 626 by 10 to the minus 34. Okay, so we have a threshold frequency. That's the lowest colour of light, the frequency of the lowest colour of light that makes this photocathode emit electrons, which are called photoelectrons. Okay, so why is this important? Well, this is important because we have to select the correct photocathode here in such a way that we can turn the lights on and off to sensitive levels of light. So in many tubes here, this cathode here is made out of cesium, C-A-E-S-I-U-M, cesium and antimony, and that gives a great general purpose photocathode that can be used in lamps across in lamps that turn lights on and off on the sides of the road. Now, if we were to choose a different photocathode that might have a higher work function, therefore it would turn on and off at different levels of light. So going to the next slide here, we are familiar now with this graph. The graph which has got E on the vertical axis, which is EK max, which is the maximum kinetic energy of a photo emitted electron. Now, there are two versions of the EK max's measurement. It can be measured in joules or it can be measured in electron volts. Now, it's important that we understand which one we're using because in a few more moments we'll see the gradient will be slightly different. The horizontal axis is the frequency. In this case, it's mostly measured in terahertz because of the high volume, values of that. And if you were to measure this, we do get a diagonal line, and let's just put it in red, going up like that. Okay. For if using a photo tube and working out the V-stop, the maximum kinetic energy. Now, it's important to work out where things are on here. This is at this point here. At this point here, let's try that again. This point here is frequency. This is F0. This is the threshold frequency, and this is the work function down here. Now, work function is a value that we pay back. It's a negative value on the graph, but phi is normally quoted as a positive number. So this can be measured in joules, as I said, or electron volts. It doesn't matter. But if this is in joules, if this axis here is in joules and this is in terahertz, then the gradient of this line is h, and that's 6.626 by 10 to the minus 34, which is the standard Planck's constant. If it's not in in joules but in electron volts, then this gradient of this line here is still h, but this value here is not 6.626 by 10 to the minus 34. It's the equivalent value for Planck's constant in terms of electron volts. So it's not the standard value. So keep that in mind. Now, this might be this graph here might represent cesium antimony. Okay, but another line, another one will be parallel to it. Let's go with the blue. Let's make it black, I think. No, it's gone away. Let's try another one colour. This one here. Okay, so here are three cathodes. They're different materials. They all just have a different work function, which is where it intercepts down here. This one here, this first line, which I would like to be in another colour, this has a higher work function. So therefore it means it has a less value of phi that requires to be paid back by the electron to leave the surface. In that case, it has a lower threshold frequency. So choosing this cathode here would mean it was more sensitive to light. Whereas choosing this last one here, it has a higher value for, when I say higher as in a more negative value, therefore a larger work function, and therefore would have a larger F0 because it's now up here. That means that the threshold frequency, the colours of light that it's more sensitive to, would be further up the blue end. So this line here, this cathode here, might be a cathode that is sensitive to yellows and green light. This one here might be more yellows and blue light, and this one here might be more sensitive to blues and ultraviolet lights. So the choice of the actual cathode is quite important. So going back here, the choice of the cathode enables us to control the sensitivity and to what frequency that it becomes sensitive to. So if you are using a general purpose light which has mostly UV, you might choose one with a higher phi function. Okay, so that's the purpose of a photo tube. Just to recap, it simply is light falls onto the photocathode, creating a photocurrent. This photocurrent is caused by the photoelectric effect, and this causes a current to be created, which is then sensed by an external circuit, and when this is going on, it will either act as a switch to maintain the status quo, or when this falls away and has no current, then it turns another circuit on. The stylized diagram that you have over here is an example of the sample answers from the 2013 HSC, where this question was asked. We were asked to explain how a photocathode worked by supplying a diagram. This is the diagram the Board of Studies has suggested was the sample answer. And here we can see the photocathode. Let's see what we can see here. That's the photocathode there. We have the collecting anode. Notice these are both labelled. Okay, and the incident light, and is the external circuit. And this is a photoelectron. It's also labelled. So this is the suggested answer, that a photocell detects light and transforms energy into electricity using a photoelectric effect. So they're very importantly that you had to understand and identify the photoelectric effect is how this thing works. You also then had to identify the terms of the photoelectric effect being threshold frequency, and though it doesn't mention here that the work function, I would suggest that the work function also needs to be mentioned. So when the frequency of light is greater than the threshold frequency, the cathode material emits photoelectrons, because the electrons have enough energy to leave the surface of the metal. Okay? In other words, the energy they're coming in exceeds the work function. So remembering that the energy coming in from the photon, that's that part, must be greater than the work function for photo emission. Okay, so that's the important part. Okay. Once again, it's mentioned this is the photoelectric effect. So the first part here is simply defining the photoelectric effect. These electrons are getting collected by the anode, and the current starts to flow in the external circuit. The current would stop if the light does not when the energy does not exceed the photoelectric the work function. If the light does not fall on the cathode, or the frequency of light was less than the threshold frequency. It doesn't go on to say how it then uses a switch in a circuit. So that would be, I would say, something which is quite important. Say that what is its function in a circuit. But that was the sample answers. Remember, sample answers do not necessarily say that they are fantastic answers. They're just a stock standard answer that would be quite acceptable. Okay, I hope this helps for you. Thank you very much.